Okay, kids, we are into the last unit. Here we go. We're going to start with something that is a bit of a review from your work in grade 9. So it's been a while, so we're going to take our time and go over that stuff. But I think some of the words you might find familiar to you. So here we go. I want you to remember something that we've been dealing with for quite a bit of time now. That all the material around this matter has a property called mass. It's measured in kilograms, and it is the source of gravity. We talked about the universal gravitational equation with big G in it, how, for example, the Earth and Moon have a gravitational pull on each other. That's because of their gravity. We're going to leave that behind now, and we're going to go to another property of matter, okay? And this property of matter is called electric charge. Electric charge. Now, just like mass has a symbol M, all right, electric charge has a symbol Q, which literally the Q is for quantity of electric charge. Now, electric charge has its own unit. Just like mass is measured in kilograms, it is measured in coulomb. Coulomb, and big C for short form, just like kg is short form for kilograms, big C is short for coulomb. It is the source of the electric force, just like mass is the source of gravitational force. And it is also part of what we call the entire electromagnetic force. As we go through this unit, we will realize that electricity and magnetism have a connection. Now let's talk about comparing these forces again. Gravity is always an attractive force. That's it. Electric force, on the other hand, is a little bit different. There can be attraction, but there can also be repulsion. You can't have that with gravity, so there's a little added twist here. Also, gravity, which is caused by mass, there's only one kind of mass. That's it. Electric charge, you probably remember from grade 9 science, grade 10 science, even in the chemistry unit. Maybe you've taken part of the grade 11 chemistry already. Electric charge doesn't come just in one kind. There's two kinds. One of those kinds is called positive electric charge. The other type is called negative electric charge. And most of the most fundamental or basic particles, the building blocks of matter in the universe, have both properties, both mass and electric charge. Yes, there's some exceptions, of course, but a lot of particles have both. So let's do a quick review of that. I know you've seen this before. Protons, P plus. Look, it's got a positive electric charge, tiny amount. 1.6 times 10 to the negative 19 coulombs. It also has a tiny mass, and it's found in the nucleus. The electron, E negative sign. Look, also has a small charge, but it's negative. The magnitude, the size of the charge is the same. See that? But the proton has a positive charge, the electron has a negative charge. Very tiny mass. Orbits the nucleus. Neutron, N with a zero, neutron. No charge. Tiny mass found in the nucleus. Now here's where we run into some problems. Some kids like to say, oh, yes, the proton has a positive charge, the electron has a negative charge, and the neutron has a neutral charge. You see how you've introduced a third kind of charge, the neutral charge? It doesn't exist. There's positive charge, negative charge, or there's no charge at all, an absence of negative charge, an absence of positive charge. Please don't make that mistake. All right? All right, so there is a law of these electric charges, and it says that if the charges are the same or like charges, they repel each other. So proton will repel a proton, or a charged particle that has a positive charge will repel another positively charged particle. Similarly, an electron will repel an electron, or an object with a negative charge will repel an object with a negative charge. They repel. This is different. We never had anything like this in gravity. Unlike charges, meaning they're not the same. They attract each other. So proton will attract an electron. See how the arrows are going together here? Positively charged object will attract a negatively charged object. And the third law is charged objects can attract neutral objects. So I think you probably remember that. We're just spending today really on review. And the last bit of today's lesson is that when we talk about this quantity of matter, this characteristic of matter called electric charges, electric charge, matter really falls into two categories. One of the categories is called the insulator. Insulators. Most of them are nonmetals like plastic, wood, rubber, and they don't allow the easy flow of charges, mostly electrons we're talking about here. Okay, and if they do gain any charge, they keep it. Insulators. Conductors. Most of them are metals, like copper. Most wires around us are copper. I'm speaking to you through my headset. It's got copper wire in it. Getting electricity to power my computer from the wall outlet. The wires are copper. They allow the easy flow of charges, and we're basically talking about electrons here. That's why it's called electrostatics, electrons. And they don't keep any charge that they gain. They are like a highway. They just let it go through. The cars arrive and the cars keep on going. Nothing's keeping them there. Here, electrons arrive in an insulator. It stays there, like a parking lot for cars. They don't move too easily. It stays there. So I have added to today's announcement a series of videos, and they come in about segments of around 10 minutes. So I would really like you to watch the first segment, and it's going to be a good review of what you learned in past grades and the rest of it, and it's a good start for us as we start this new unit. I hope you all had a lovely weekend, and we'll talk to you soon. Bye-bye.